Asha, so this is going to be a lecture on the second question. The second question says that let A be an array of n elements where there is a target element A which occurs k times in the array A. Okay? Design a randomized Las Vegas algorithm to find an index of the element k. Now, Las Vegas means you will keep, like, there'll be a random aspect to your algorithm, but it will keep running till it finds out the exact answer. And what do we mean by answer? We want to find an index of our element, of our target element. So फर्स्ट कर लीजिए हमारे पास एक array है, उसके अंदर n elements हैं. ठीक है, there's n elements and there's a target A and k जगहों पर वो भरा हुआ है. Now if I check a random index in this array, the chance of me finding the target element A is going to be k upon n, because k of these locations are filled with our target element, right? So if they are, the probability of me finding in a random location our target answer is k upon n, then the expected number of tries I have to make to find him is n upon k. And once again, the explanation for this is in the previous tutorial. You can see that if you want an explanation. But our randomized algorithm हमारी जो होगी is just going to be keep looking at random indexes and don't bother with keeping an array for, like, don't bother with optimizing कि अच्छा हम we will only be searching over the unvisited elements. कि ऐसा नहीं है कि हम array से किसी तरह उनको pop करके निकाल रहे हैं. We'll just keep looking at random indexes, and if we get to the same random index फिर से, which is fine, that's fine. That's just how our algorithm works, because they didn't say हमें ऐसा कुछ करना है. We just had to find a Las Vegas algorithm. Las Vegas हमारी algorithm है क्योंकि वो random तो check करते रहेगी, लेकिन it'll keep running until it finds the element that you're trying to find. Now technically इसका runtime infinite हो सकता है if you keep looking at the wrong place, लेकिन there's a very unlikely chance of that happening. And the expected runtime, the expected number of iterations you expect to make before you find the element is n upon k, where k is the number of occurrences of that element. Okay. Now we'll do question 3. Let A be an array of n 100 numbers, which again are distinct, and n can be greater than 100 as well. Design a randomized Monte Carlo algorithm to find element A in with worst case running time of 1. ठीक है, so they're saying Monte Carlo algorithm बनानी है. We want to have a constant runtime. A constant runtime हमारी बहुत simply आ जाएगी just by saying कि there is a maximum limit on your iterations. So let's say for example, अच्छा सवाल क्या है? Define element A in A. ठीक है. Now they are, let's say n is exactly equal to 100. उन्होंने कहा greater than 100, but you get the idea. So let's say there is an array, and array A has n elements and n is equal to 100. ठीक है. And we want to find a target element A. Now obviously there has to be exactly one occurrence of A, ठीक है, because all of them are distinct. And so if I just randomly go and keep checking locations in the array, then the chance of me opening a location with the target element is going to be exactly 1 upon n. So the chance of me not finding him is going to be n minus 1 upon n. So the simple Monte Carlo algorithm for this answer is going to be just check k random locations. K random locations also, like, it's a little misleading. We're going to just check random locations k times. K distinct नहीं होनी चाहिए. We're just going to keep checking random indices. तो हमारे पास अगर 0 till 99 के indexes हैं, so we can, like, the random function might go to the same index again and again. ठीक है, लेकिन that's just how our algorithm is going to work, because it's a Monte Carlo algorithm. We don't guarantee कि हमारा answer सही आएगा, that हम return कर देंगे element की index, like we will find it. We don't confirm that, लेकिन by varying the number of iterations our algorithm is locked at, we can increase the probability of it happening. अच्छा, so let's just say k is equal to, let's say 50. ठीक है, so we're gonna check 50 random locations. ठीक है, 50 बार हम random index को देखेंगे, random को देखेंगे. Now keep in mind I said we are not checking we're not like optimizing this in any way. We're not saying अच्छा एक element को visit कर लिया तो अब उसको हटा दिया या उसको किसी तरह कम कर दिया अपनी search space को. We will keep checking random indexes. तो in the first iteration, the chance of me not finding him, अभी मैं error निकाल रहा हूँ क्योंकि the second part of the algorithm was कि what is the probability of error in your solution. Error का मतलब है what is the probability that my algorithm, after running for the constant fixed time that it was designated, it does not find the answer that you were looking for. So the chance that I don't find it in the first, let's say k is equal to 50, so we're going to make 50 random iterations of checking random indices in the array. What is the chance that I don't find the element in the first iteration? Well, it's n minus 1 upon n. And in the second iteration, it's n minus 1 upon n again, because, you know, exactly as I previously said, we're not optimizing this anyway. So I'm still checking any random location. I can still check any of the n locations, and abhi tak we obviously we answer that n minus 1 of them don't have the target element. Exactly, one of them has the target element. I have a 1 upon n chance of finding him. I have n minus 1 upon n chance of not finding him. Now I do this 50 times. So I'm just going to multiply this. So, you know, this is an independent event. The probability of 50 tries not finding a given element is simply going to be n minus 1 upon n multiplied by n minus 1 upon n 50 times, which can be simplified, as n minus 1 upon n to the power k, or in this case 50. Okay? So given that my algorithm runs for k iterations, rate of error is going to be n minus 1 upon n to the power k. And you can define k or you cannot define k, that's up to you, but that solves your answer.